Lesson 9, day 3, using an equation to find slope and y-intercept. Read the problem below, then explore different ways to find the slope and y-intercept for a linear function when an equation is given. A telephone plan charges a regular monthly amount plus charges for the number of minutes of use, x, as shown in the equation y equals 0.1 x plus 40. All right, so if you're given an equation, again, we have the y equals mx plus b, which is our slope-intercept form. And as you can see, they gave us an equation that's in this exact form. So we have our m already, and we have our b. M is your slope, while b is your y-intercept. So without even looking at anything else, we should know that our slope is 0.1 and our b, which is our y-intercept, is 40. Okay, so this means we should be able to identify what this means given the rest of our problem. So the plan charges a regular monthly amount plus something else. All right, regular monthly amount is going to be our initial fee. And we all know that initial fee is the same thing as initial value, which we now call the y-intercept. So our y-intercept is the regular monthly fee. Making the slope be the number of minutes used is our x. So that means our slope needs to be the amount they charge per minute. Okay, now let's confirm all these details with our model it and graph it and then answer our connected questions. All right, model it. You can use a table to find the slope and y-intercept of a function and substitute the x values into the equation to find the corresponding y values. They already did it, so I'm not going to do it, but you totally could. I'll do it one time just so you know it's correct. So let's say when x equals 100, our y should equal 50. Let's plug it into our equation to make sure. So we have y equals 0.1 times 100 plus 40. Well, 0.1 times 100 is 10 plus 40 is 50. So when our x equaled 100, our y actually did equal 50. So yes, it's fine. All right, the graph it. You can graph the order pairs from a table to show the slope and y-intercept of a function. So they're getting these order pairs from the corresponding x's and y's. So we have this first order pair of 0, 40. Then we have 100, 50, and so on and so forth. Okay, every x has a y. Okay, and you keep on going. All right. Then they say, well, you know what? You can use 2 points on the graph, for example, 0, 40 and 100, 50 with the formula y2 minus y1 divided by x2 minus x1 to find the slope. Again, this is our slope formula they're discussing. Okay, so let's go ahead and choose it. And I won't choose the same ones they already gave us. I'll just choose 2 of our own just so we can know that any 2 will work. It does not matter. Okay, actually, I'm going to go further with that. I want you to know that it doesn't have to be 2 points that are right after each other. You can choose any 2 points on the line. If it's a straight line, you should be able to find the slope. Okay, so let's do y2. Let's make this point 1 and this point 2. So we have our x1, y1, x2, y2. So let's do x or y2, which is 60, minus y1, which is 40, divided by x2, which is 200, minus x1, which is 0. Okay, so we have 60 minus 40, which is 20, and 200 minus 0, which is 200. I can go ahead and cross out these zeros, which is the same thing as dividing by 10. So I've got 2 over 20. I can just divide by 2 over 2. And I've got 1/10, which is the same thing as 0.1, which we know is our slope, back from our equation from earlier. So we are good to go. All right. Remember on the last day, we also talked about you could also just draw a triangle if you're a visual learner and you like that. Then you could just say, well, how do I get from one point to the next? Well, let's just choose these 2 points here. So I can go up and over. Up from 50 to 60, I've added 10. And from 100 to 200, I've added 100. So my rise over run is my slope, which is my M, is equal to rise over run. I went up 10 and I went over 100. That's 1/10. So I get the same thing every time, no matter how I do it. If I can use the slope formula or I can draw it out and simplify it, that works as well. All right, moving on to the connected. Now you can examine the equation, table, and graph to find the slope and y-intercept. You know that the y-intercept point always has an x-coordinate of 0. What number can you substitute for x in the equation to find the y-intercept? Since the y-intercept point always has an x-coordinate of 0, just go ahead and plug in 0 for your original x in your equation to find your y-intercept. So our equation is y equals 0.1x plus 40. I couldn't remember, sorry. So let's just plug in when x equals 0. All right, so y equals 0.1 times 0 plus 40. So anything times 0 is 0, so it's gone. Y equals 40. So our y-intercept, of course, is our plus b part. So our y-intercept is 40. All right, verify that your answer to problem 9 is correct by describing how the table or graph shows the y-intercept. I'll do both just in case you just which one, so you can go ahead and check your paper as well. In the table, when x is 0, y is 40, so that's how we know it's our y-intercept. In the graph, it's where our line crosses the y-axis. That's how you know it's the y-intercept. Okay, and again, you can just check that here. Our line crossed the y-axis at 40, and our table, when x was 0, y was 40. There you go. Number 11, explain how to find the slope using the table and graph. Find the slope using the table and graph. Again, we already did this. So using the table, all you have to do is figure out how to get from one y value to the next, one x value to the next, and divide the change in y by the change in x. Okay? So for the table, you would find the change in y and divide it by the change in x. That'll give you your slope. So what I mean is if you have your x and your y, you got 0 and whatever else they got. What else do we have? 140 and 50. 140 and 50. Okay? To get from one y to the next, we add 10. To get from one x to the next, you add 100. So our slope is going to equal the change in y, which was 10, divided by the change in x, which was 100. So our slope, we're just going to simplify it, is 1/10, which is 0.1. In a graph, all you do to find your slope, you have two options. You can draw out your little triangle, and you could say, well, I rose 10, went over 100. Or you can use your slope formula at y, which is y2 minus y1 divided by x2 minus x1. Okay, so you can just use your slope formula, or you can do rise over run. Okay, so explain how the equation y equals 0.1x plus 40 shows the slope and y-intercept. Using the slope-intercept formula, which is y equals mx plus b. 0.1 is in the place of m, and 40 is in the place of b. So we know that m stands for our slope and B stands for our y-intercept. Moving on. What do the slope and y-intercept mean in the context of the problem? All right, our slope here represents, and we already did this again, our slope represents the charge per minute, and our y-intercept is the regular monthly fee. So our slope is the amount of money charged per minute, while our y-intercept is the initial monthly fee. Yeah. Okay. Number 14, describe two different ways to find the slope of a function and two different ways to find the y-intercept of a function. Two different ways to find the slope. And again, we've done this so many times, so that's why I was laughing. Slope could equal the rise over the run. So you could kind of use a graph to do that and just kind of say, how many do I go up? How many do I go over? Okay, you could say how many up, how many over. That's my rise over my run. Okay, or you could also do find the change in y divided by the change in x. This is when I'm using a table. This is when I'm using a graph. And I could also, either way, I could do my order when I'm doing ordered pairs. I could use my slope formula. So which is y2 minus y1 divided by x2 minus x1. And two different ways to find the y-intercept of a function. Well, when I'm looking at a graph, I don't know why it's doing that, I'm sorry. When I'm looking at a graph, that's when my line crosses the y-axis. If I'm looking at a table, it's when find where x equals 0. Your y value is going to be your y-intercept. And finally, what else you could do to find the y-intercept when you're looking at an equation, and I forgot to put that for both. So when looking for a slope or for the slope or the y-intercept, you could also, if you're given the equation in the form of y equals mx plus b, your m is your slope and your b is your y-intercept. Again, they only ask you for two different ways. I'm giving you several. Okay. Several. Okay. And our try it. Use what you just learned about slope and y-intercepts to solve this problem. Show your work on a separate sheet of paper. So a different telephone plan charge or includes a monthly payment of $50 plus a charge of 5 cents per minute for calls. Write an equation for this function. Identify the slope and y-intercept. Super easy. They already told you what they were. So they've got the monthly payment of $50, which is going to be our y-intercept. And they've got a charge of 5 cents per minute for calls. So the 5 cents per minute is going to be our slope. Again, we just need to put it in the form of y equals mx plus b. So we've got our y equals our m, which is our slope, which is 0.05, x, which is our number of minutes, plus the monthly payment of $50. That is it. And it says identify it clearly. So we're going to have our 0.05 is our slope. And of course, 50 is our y-intercept. Okay, and moving on to day 3 continued, the next set of textbook pages. All right, writing equations with a negative slope. Read the problem below, then explore different ways to understand negative slope. Elena is training for a bike race. She makes this graph to show the relationship between time and distance if she maintains her planned speed. Write an equation for this function, then identify the slope and y-intercept and explain what each means in the context of the problem. Okay, so of course, her bike race starts off at 20. Since it starts off at 20, that lets us know that's the distance from the finish line. So she starts off 20 miles from the finish line. and this is our y-intercept. Every 20 minutes, she's going to do every 20 minutes, she's doing 5 miles. So she's getting 5 miles. So that's what she anticipates on her doing. So we're actually going to go down 5. So minus 5, but still over 20. Okay? Minus 5 over 20. So to find our slope, what we would do is we'd have our rise over run. Just because our rise is negative just means we're going to put a negative there. So we went down 5 over 20. Still to the right 20, so our 20 is positive. So our slope is actually going to be negative 1 over 4. So that means every minute she should be taking off 1/4 of a mile every minute. So she should be covering the distance of 1/4 of a mile, 1/4 of a mile every minute. Elena should, let's say travel. I was going to say cover. She should travel 1/4 of a mile each minute. Okay, and since we have our slope and we have our y-intercept, we can easily write an equation which needs to be in the form of y equals mx plus b, which is our slope-intercept form. So y equals our m, which is our slope, negative 1/4 x plus b, which was 20. All right. So again, our y should represent the distance from the finish line which you can just get from the graph, super easy, because the y-axis represents the distance from the finish line in miles. The x is going to represent the time or the number of minutes. 1/4 represents our slope, of course, which is the amount traveled, or the distance traveled per minute. Pretty sure I just spelled traveled wrong, but whatever, I'll fix it. Whatever. Okay, distance traveled per minute. Okay, and then of course the 20 represents our y-intercept, which is the starting distance from the finish line. Starting. Okay. All right, model it. You can make a table to find the slope and y-intercept. So you could do that. So just give some points for x. When x equals 0, y equals 20, so on and so forth. So you can tell that to get from one x to the next, you add 20, and to get from one y to the next, you subtract 5. So to find your slope is a change in y over the change in x. And that triangle I'm drawing, it just means the change. Okay? All right, my change in y was -5. My change in x was 20, so my slope is negative 1/4. Again, we already had that at the top, and that is perfectly fine. You should be able to find it in any way that I give it to you. Okay, and then of course you'd be able to find your y-intercept by looking for when x equals 0. When x equals 0, you find what your y value is. That is your y-intercept, so it's 20. All right. You can use the information from the graph or table to write an equation. Use the equation y equals mx plus b. Substitute the slope for m and the y-intercept for b. So this matches exactly what we had at the top, was y equals -1/4 x plus 20. Moving on to the connected, now you can relate the slope and y-intercept to the information in the problem to interpret their meanings. What do 0 and 20 represent on the y-axis of the graph? How long is the race? 0 represents 0 miles from the finish line. 20 represents 20 miles from the finish line. So they both represent miles from the finish line. How long is the race? The race is 20 miles long. Moving on. What do 0 and 80 represent on the x-axis? How many minutes will it take Elena to finish the race? All right, 0 and 80 represent time, the amount of time it takes to finish the race. Oh, yes, 0 and 80 represent time in minutes. And how many minutes will it take Elena to finish the race? Elena anticipates it's going to take her 80 minutes. Okay, moving on. 18, fill in the blanks to show the meaning of the slope. As the time spent racing increases, the distance from the finish line decreases. So as the time spent increases, the distance decreases. Okay, so looking at our graph, as we move along in time, our line is going down. Okay, the distance gets smaller because she's covering a certain amount of distance every minute. Okay, for every 20 minutes, the distance from the finish line decreases by, remember we did that one earlier, for every 20 minutes, it decreases by 5 miles. The slope, -5 over 20, or -1/4, we just simplify it, means that each minute, the distance from the finish line decreases by -1/4 of a mile. Okay, -1/4 of a mile. I'm sorry, I shouldn't have said -1/4. It just decreases by 1/4 of a mile because we already said decreases, so you didn't have to make it negative. All right, what is the y-intercept? The y-intercept was 20. And what does the y-intercept mean in terms of distance from the finish line? The racers, I really don't know what they're called. The racers or bikers, whatever. Bikers probably sounds better. Bicyclists. Oh, that was dumb. The bicyclists begin the race 20 miles from the finish line. That's all it means. All right, number 20. Summarize the meaning of the slope and y-intercept from the problem on the previous page. The slope, -1/4. So let's just write that out. The slope, -1/4, means that for every minute, the distance remaining in the race decreases by 1/4 of a mile. The y-intercept of 20 means that the race is 20 miles long. Okay, great. Or 20 miles long, 20 miles from the finish line. Okay, moving on to the try it. Use what you just learned about negative slopes to solve this problem. A storm moves at a rate of 8 miles per hour. If that's the rate, it's literally the rate of change, which we now call the slope. Slope is 8. It is 200 miles away from Freeport and is headed directly for this town. All right, the equation 200 minus 8x can be used to represent the function. Identify the slope and y-intercept and what they represent. Again, they already gave you the equation, which I think kind of takes away some of the point of doing this, but okay. So 200 minus 8x. Again, if we're looking at the slope-intercept form, we can write it just like that if we want to. Keep it like this if you know how to do it. If you don't, just switch the order. Do -8x plus 200. So our -8 is going to represent our slope. And our 200 represents our y-intercept. So the -8 represents the change in the storm's distance from Freeport each hour. So the slope, -8, is the slope, and it represents the distance from Freeport. The distance of the storm. The change in distance of the storm. Okay, from Freeport. Okay, while the 200 is our y-intercept, and it represents the current distance from the storm. Okay, so again, the slope is the rate, and the rate of change is the miles per hour. So this is just the speed. Okay, the speed of the storm, while the 200 is how far it's away from Freeport. Okay, and that is it for our try it. Go ahead and practice what we've learned for this day 3, which was a lot, I know, but you should be able to summarize everything we've done in these workbook pages by practicing them in their workbook pages 95 through 98. Thank you.